Okay, I guess I'm live. Let me start the timer and tweet about it. Yes, I am live. Okay, let's start with today's work, which is just continue continued like test from last year. Yesterday, not last year. Yesterday. So we are somewhere down here. Yes, and we are trying to get this value, right? Get random 52 bytes because we needed to pass them in the paymaster. Okay, let's see. Yeah, paymaster data. If you didn't, let me. Okay, I guess someone else is watching today other than my brother. If someone is watching, please say hi or anything else, and I'll ping you back on the chat. Thanks for joining. Let's see. Yeah. So I was talking about this yesterday. I was testing this function from ERC4337 entry point, which basically does like it gets the packed user operation and it unpacks the user operation and stores it in the memory only. So this doesn't change. That's why I exported it in a different way. So let's close this here. Expose copy. Yeah. So I created this memory user op in this function and return that. So I have access to this memory user op and also the packed user operation. That way it's simple for me to test it. Here I'm creating the packed user operation. I have this random 52 bytes. Yeah, 52 bytes. Then here it will be empty. Why? Because in the copy user operation you can see it doesn't do anything on the signature. Like, there is nothing to unpack or modify or cross check. Like there should be a signature and that value will be checked by the account contract and not the entry point, so it doesn't really care. Now we can call entry point dot expose entry point dot expose underscore copy user op to memory and then pass the user op to it. We can save the return value by, is it entry point sorry, point dot memory user op memory and then m user op equal to with this m user op initialized we can start our assertions. So m user op, let me close this, yeah, and put it on the side. Memory, sorry, not memory user op. Okay, so you can see these values are here. Now it's unpacking, I guess. Yeah, it's unpacking bunch of values. Okay, let me, instead of random 52 bytes, we can construct the actual. Yeah, let's just remove this. For next test, we'll use that function, slice function, where we'll get the 51 bytes and see if we are getting the correct error. Right now, we just need to ABI dot encode pat and then add the address, which is 20 bytes, 123. Then uint 128. This is the paymaster verification gas limit, which is 16 bytes. And then uint 128, 50,000, which is paymaster post stop gas limit. So we have total of 52 bytes. Address 20, uint 128, 16, 16, 32 plus 20, which is 52. Okay, let's rename this also. Paymaster and data. It needs to be at least 52. It doesn't need to be less. Like if it's more than 52, it works because the entry point expects the paymaster to handle the data part. Okay, now yeah, we need to change this name to paymaster and data. Okay, verification gas limit, which should be 50,000. Then call gas limit should be 40. Yeah, we have changed the values. So let's select 60. Oh, paymaster and data. This should be 40. Now next part is okay, paymaster verification gas limit should be 50. Paymaster post stop gas limit should be 60. Just I'll just comment here so that you guys can remember. First will be paymaster address, paymaster address, then paymaster verification gas limit, paymaster post op gas limit. Here, can I add it? Yes, I can. Here, I think first is verification, verification gas limit, and then call gas limit. I can show you this in the EIP itself. Let me open that up and then show you. Okay, why the browser window is not showing up? Okay, let me open a new browser window. Yes, it's now there. eip.ethereum.org. Okay, let me fix this. Sorry, again some error. Yeah, you guys can now hopefully see it. ERC4337. Okay, it's here. And this user operation. Yeah, packed user operation. You can see verification, then call, and last part was this one, which is max priority fees per gas. Fees. No, fee per gas. And then max fee per gas. Okay. So just keep this in mind. How we are coming to this conclusion is using that. So we have done paymaster. Then we can say, oh, we haven't checked the address of the paymaster, which should be address and 123. We can put 4 also. Yeah, that way it's correct. It doesn't matter, but I still want to do that. Keep the sender address and the paymaster address separate. Okay, next part is the gas. So max priority fee per gas is 30, and then max fee per gas is 40. What? Okay. Okay, this was wrong here at the top. We can restrict this to pure, I guess. Okay, where is error? Not pure. Let's restrict this to view. Okay, let's run the test and hopefully we are correct. I guess I am. Yes, so it is parsing everything correctly. Now, what we can do is, we don't like copy pasting. So let's write the whole thing. Function test copy to memory reverse. Then we can say external view, go down, First is we need to construct the call data, not call data, the paymaster data. So memory, paymaster, and data. Okay, I know I don't want to copy, but let's see. So we are expecting a revert. That's why I didn't copy the assertions, because after the revert nothing will work. vm dot expect revert, and the error will be underscore copy user. Okay, error is this. A93, double A93. What's happening? Okay, we that works. Now we can slice it. Slice paymaster and data to 51. Let's see what's the issue. Tuple, I don't know why. Why would that be? Slice bytes. Okay. Okay, now that's done. Let's copy the name and run the test. Yes, it works. Let's see the trace. Yep, you can see revert, and we got the correct revert. Okay, I know I said we are going to start with the paymaster, but let's write down the things like we have done till now. Entry point, boundary, working on rewriting, not rewriting, like I'm not writing the project, but like rewriting slash testing the entry point implementation by ETH infinitism with boundary. Okay, functions, covered functions. Let me open up the, what was that? Solidity matrix. Yes, solidity matrix. And we'll have all the function names and we can check them off. Can I do this, or is it? Yes, that's too much work. Okay, let me Google. get all the function names from the contract. Solidity. Can we, do we have this? Okay, no, I guess that's not the case. How can I get list of all function names from Solidity contract with, okay, just a second. Yeah, we can do it with cast. Would you inspect? Let's see. Okay, uh, yeah, this can change this to source slash entry point dot sol slash, oh sorry, source slash core slash entry point. That should do it, man. That should. Why entry point it works? Inspect. Can we just put entry point? Yes. Okay. Got it. Let's close this. Okay. No, it doesn't give the internal functions, so we need another command. Let's just run. Okay, so let me see if I can see the whole thing. Yes, I can. Now type function. Let me underscore copy. No, that's not there. Okay, I guess there is no way to go about it. Okay, let me run another command. Inspect entry point. Okay, I guess we just have to do it manually. clear. What else is there? No, nothing. I just like this is much easier way to go about it. Okay, just give me list of sorry, list of function names. Okay, I just asked ChatGPT to like filter out the data, filter out the whole thing, so I don't have to copy it manually. And with this, can we just remove this temporary, then put this? No, yeah. Mm-hmm. No, just a second. How much time do we have remaining? It's 32 minutes. Okay, so today's stream was not that fruitful, but last few streams has like the last few streams were very fruitful, so that cancels it out. We have done this. We have done this. We have done this. No, we have done this. Yes, yes. Don't know. No, we have done this. Get validation data. I don't know. Let's see our test and the exposed functions. Get validation data. Okay, we have done that. Validate paymaster and okay, but I don't know if okay we have done it. Compensate okay. Emit okay. Emit prefund tool okay. These two egg 1 2. Then get prefund get required prefund. Where is that? Yes, we have checked it. Then this function copy get user gas price. Get user gas price. Okay, this function we have done it. Next is account validate account prepayment. We have done that. Okay, so we have done these things, we have a lot of things remaining. Yeah, the question was this function. So it was here. Yes, I have to see if validate okay, validation data. Yeah, we have tested it then, because paymaster data validation API. Okay, so this is just um, time and time out, like the time range and the signature validation. Okay, so that works. Let's see packed user operation. Sorry, execute user operation, which is this. Let's see what that function does and see if we can test it. Nope, I don't want to touch this right now. Not in the mood, and don't think I would be able to handle this. Memory safe collected. Then it checks if not success. Bytecode. Uh, Inner revert. Don't know how to get there. This out of function error. Handle off was called with low gas with gas limits too low. About entire bundle can only be called by bundler, leaving not enough gas for inner call. Okay, guess that can be done. Inner call reverted on prefund too low. Treat entire prefund as gas cost. Okay, okay. I have to see how this thing works. This assembly block whole, because I don't understand that block. That's why I can't test all these things also, which are basically, yeah, which are basically dependent on that this block. I'll read about it today and see how to test it. Not today, tomorrow. Get sender. This is related to factory. We have done. Okay, let's. Okay, so we have time. Let's see the paymaster how to create that. Okay, so semi abstract nonce validation. No, paymaster. Okay, so before this, we need to understand the refunds, how refunds work. Forget this part. Create init code. Let's say a bundler sends some user operation to handle ops via, like, by creating correct function, by creating correct transaction. Then first validation starts, like validation of first user operation. It checks, like, with account contract for each user op, like if the user operation is different, it'll check with the it'll check with account contract if the user operation is valid. If it is valid, then it will return some value which was seg validation success, like in our case, if you remember the value. And if it fails, like validation fails and we move on, at that point the account contract sends the ETH which are needed for executing and validating the user operation. Here there is a deduct account deposit step. So we need to understand the deposits, like what are those deposits are basically deposits on entry point for paying the gas. So if there is less deposit than the ETH required for executing and validating user operation, then entry point will say to account contract, send me some ETH for doing all the operations, and account contract will hopefully send correct amount of ETH. And the assumption is the account contract is not malicious, and bundlers and the whole network will check it in any way, so you don't need to think about it. But if it is malicious, we can't do anything. Assume it's not malicious and it sends the deposit, sorry, it sends the transaction fees. But if deposits are high enough, there won't be any amount sent to missing account funds sent to account contract, and so there is no ETH transfer. So it just deducts from deposit and pays back to bundler. At here you can see compensate beneficiary. Here that ETH will be sent back. Now after validation, if validation, like the validation loop continues till every user operation is validated, then execution starts, where same thing happens. There is a call data, and that call data will directly get executed on the account contract, and account contract should know how to handle it, because we are the one who are constructing that call data. So assume that account contract knows how to handle that call data, and the execution loop happens. At the end of it, the beneficiary gets compensated. Now you saw in the in this scenario, for paying the gas fees, we are using deposit of account contract, or account contract is sending some ETH. But paymasters are the entity who are paying for the transaction fees for any account contract. It's not like it depends on paymaster, like who they want to who they want to pay for. And account, here account is the account contract. Here the first account is the one for which paymaster will pay the data, pay the transaction fees. In that scenario, validate user op will first validate the account, and the packed user operation, if there is a paymaster, if paymaster field is not empty, then it doesn't is not empty, then it sends 0 as a missing account fund. Then it goes to next step, where it checks with paymaster if the paymaster and data field it's correct, or paymaster is willing to pay for the account for to reimburse the transaction fees to bundler. If paymaster says yes, with correct validation data, it deducts the deposit from paymaster. It deducts the transaction fees from paymaster's deposit. So when when an account is using paymaster, there is no ETH transfer between entry point and paymaster because it's much efficient. ETH transfers take few like few hundred or few thousand gas here and there, so that will be reduced, and the deposit paymaster deposit will get deducted for the transaction fees that bundler is spending to get the user operation validated and executed on chain. Then execution loop continues. Just one step is added where in the post op, it if there is a context, we'll learn about what is context. But if paymaster returns some context, then the post op function on the paymaster is called by entry point, and paymaster does something. After that call is executed, refund happens to paymaster deposit, not account contract, because account contract is not the one who is paying for the transaction fees. So if there is a miscalculation some or the payment sorry if there is a miscalculation of gas fees, like the user operation is paying more, this refund will refund the remaining amount to entry point, and correct amount will be paid to beneficiary. Now we come here. This is the interface for the paymaster, where we need uh, two functions to be implemented on any paymaster. But if you see in the account abstraction repo, let me switch to VS Code. We have a base paymaster. Yeah, hopefully this is base paymaster, and it has implemented those two functions, which were validate paymaster user op and then post op. These two functions are needed. Similar to account contract, we are gonna inherit the similar to how we did in simple account, which was inheriting base account. In the paymaster, we are gonna inherit base paymaster and write the functions. We need to write underscore validate paymaster user op, and you can see here it returns two values: validation data and context. If we return context, like non-empty bytes, non-zero bytes, the entry point will execute post of function. But if we send 0 bytes, it won't. If it sends, you can see here. If we send non-zero bytes, we need to override underscore post op. Otherwise, it will revert. Like it says, revert must override. If not used, we can keep as it is. In our case, we are not going to use post op. We'll try that afterwards when we are writing a paymaster which takes like ERC20 tokens as a compensation for paying the gas fees in native token. But right now we can write a simple paymaster. Let's create like paymaster dot soul. Let's say pragma 0.8.24 MIT contract paymaster. Okay, now that we have done this, we can import the base paymaster from source base paymaster from source / core / base. Okay, I guess you if you didn't hear my voice, I was talking about like I created this empty contract, and then we are gonna import the base paymaster from the correct like path, which is base source slash core slash base paymaster dot soul, and we can inherit this base paymaster. Okay, we can see this. It will say mark it as abstract because we need to implement this function, and also we need to create the constructor which takes entry point. Let's see the base paymaster constructor and see what's there. So you can see it takes entry point, so we need to give this value. Let's import the I entry point interface from I entry point from source slash interfaces slash I entry point dot soul. Okay, interfaces, we can say entry point is equal to entry point base paymaster, then pass that value entry point. Oh sorry, yeah. Now for validate user op validate paymaster user op, we can just copy the function signature. Yes, so this is the one. Come here, remove this, paste this. Okay, we also need to import packed user operation. Packed user operation from source slash interfaces slash packed user operation dot soul. Now what's okay, we need to override it. Now for our paymaster, we are gonna keep the logic simple and use white. We are going to only pay for the addresses which are whitelisted. So for that, we can create a mapping which has address and boolean, then private whitelist. I think I remember. Okay, don't know why we need to add this. We don't need to, but I'm just adding it. Okay, and you saw in the base paymaster that this is base paymaster is inheriting ownable. So whitelist function we can restrict to only owner with only owner modifier. If you haven't seen that, like how OpenZeppelin works or what is ownable, go to OpenZeppelin slash contracts or just Google OpenZeppelin contracts, and in the access section there should be like ownable, or yeah, there should be ownable. Let me show you access ownable. Okay, and we have this modifier only owner with which we can restrict the access. So function add address to whitelist. It will take argument of type address account contract, and then say external only owner and will change whitelist account contract equal to true. So it is now whitelisted. We'll do same thing, remove address from whitelist, address account contract external only owner and whitelist account contract equal to false. We have this. So our mapping is private, which is why we need a view function. Check if whitelisted. We'll say address account contract external, not external, public view. Okay, and then returns boolean, which is return, and now we are gonna return the actual value, which is whitelist and account contract. So this is our whitelist logic. We have add remove, which is access controlled, and we have check, which just checks the value. Now here we can have a if else block. If whitelist, and we can access the account contract address from user hop dot sender return. We need to return a tuple where we need where will return empty bytes and the validation data. Let's write the else block first. Else return x. Okay, for validation data we are gonna just use what we used previously, which is this, like validation fail, validation successful. Okay, source slash core slash helpers dot soul, and if whitelisted we're gonna return seg underscore validation success seg underscore validation failed. Okay, we have completed this. User operation hash, then max cost, and we can restrict visibility, like we can use view here. With this our paymaster contract is done. We can start testing this tomorrow and see if there is any issue with our logic. It's pretty simple, so I'm sure there isn't any issue, but it's still better to be safe than sorry. So we are gonna write the unit tests and the integration tests. In the unit test, we know like we are going to test each of this function, and in the integration test, we are going to create a packed user operation which has the correct paymaster and data field, and send it to entry point to see if it gets executed and validated. So that's the idea for tomorrow. I guess that's it for today. Thanks for joining the stream, and hopefully you'll join tomorrow's stream to watch this. So okay, bye bye, and see you guys